Logan's dad, no, he emailed me, and he said Logan's sick. So do y'all have a message for Logan?
Yeah, you suck.
Okay.
He was sick yesterday.
We miss you. Yeah, you didn't look sick yesterday. Maybe he's faking it. Logie. Okay. What? I'm not going to put the midget. Okay. He is at very nice height. Okay.
He's short.
There are things he can do that you will never be able to do. Crawl through a small hole.
I know you.
Or
Not right.
play on the McDonald's playground. Just kidding, Logan. I know you're too tall for that.
No, he's not.
All right. Recall. Okay.
You are. I got stuck.
All right. So let's get to work. Inverse functions. Okay, we learned some things about them the last few days. We're not going to do the really long crap we've been doing the last few days. We're going to AP-ify it, okay? So what is true about the domain and range for a function and its inverse? They are reversed. Okay, so remember that domain and range are reversed for f and f inverse. Also, their slopes are reciprocals. There you go. Yep. Okay, and remember that they're not opposite. Sean, you gonna get in on this? Okay, they're not opposite reciprocals. They're the same sign reciprocals. Okay, you can make conclusions about an unknown function given information about its inverse. So notice that in our table we have f and g. We don't have f inverse. We don't have g inverse. But because we know about the relationship between them, we don't have to worry about finding the functions like we did on our homework. Okay, we can just make conclusions. So the first one says, suppose h and f are inverses to each other. That's what that means. H is f's inverse. Write an equation for the line tangent to h at 5. Okay, this is how I'm going to do it. So I'm going to put f on this side, and I'm going to put h on this side. Now remember, what's the relationship between f and h? They are inverses to each other. Okay, I want the tangent line to h at 5. So that means that for h, it's going to be 5 comma something, right? Because I need a point. And then what else am I going to need? A slope. Very good. Now think about the domain and range for f and h. If they are inverses to each other, is reversed. So if 5 is h's x value, what is it for f?
It's going to be something 5.
Something comma 5. It's the y value. Very good. So look in your table for what x value is f 5. Ding, 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 right here. So 2 comma 5. So that means that for h, what's the ordered pair? 5 comma 2. Okay, aren't you glad we did 1,000 of these? Okay, now if I want the slope, I need to know f prime at 2. So look back at your table. I'm right here at 2 still. What is f prime? 3. What is the relationship then between this slope and this slope? Even though I'm not going to do all the crappy math that we've been doing the last 2 days, what do we know it should come out to be? 1/3. And then from there, can I write the equation of the tangent line? Because they're reciprocals, correct. So it'd be y minus 2, 1/3, x minus 5. Okay?
Heard.
Great. All right, next one. Okay, we have j equals g's inverse. That means that g and j are inverses to each other. Okay? For j, we want it at x equals 0. That means that it's 0 comma something. Okay, what does that mean the ordered pair is for g? Something comma 0. So look at your table, and I want you to find 2 things. The x value when g is 0 and the slope at that same value. What is the x value when g is 0? 3. You see it right here? Here's my 0, my x is 3. And what is g prime at that value? 1/2. So if the slope for g is 1/2, then what is the slope for j, which is its inverse? 2. Now, I also forgot to complete my point. If for G it's 3, 0, what is it for J? 0, 3. Then I have my point and my slope, so it'd be y minus 2, or wait, y minus 3 equals 2x minus 0. Alright, I want you to do C and D on your own. Give it a shot. You should be able to do both of those. Except instead of having to write the whole equation of the line, what are you finding? Only the, if it's q prime, that would be the slope, right?
What's the slope of Q prime?
Okay, so what are my two functions? F and
G.
that's supposed to be a
Well,
q.
F and Q.
Okay? So then for q, what's q's x value? Look at how it's written. Q prime at 2. That means 2 is the x. Well, if 2 is the x for q, what is 2 for f?
The Y.
The y. So look on your table.
0.
F is 2 when x is 0. That is
So
correct.
the 0 is the Y for Q.
0 is the y for q, correct. Now, where do I go to find the slope for f? F prime at what? 0. Very good, because you need to use his x value. What is f prime at 0?
So -1.
And what is the reciprocal of -1? Still -1. So q prime at 2 is -1. Okay, but remember, if it had come out to be another number, you would have reciprocaled it, but -1 just happens to be the same. Okay, now can you do D?
Yeah.
Okay, now do D. Okay, so what's my ordered pair for P? What's my X?
3, 2.
3 something, which means it's something 3. And then when I look at my table, I can see that G is going to be 3 right here when X is 2. Then from there, to find my slope, remember, my table does not have P in it, but my table does have G in it. What am I looking for G prime at?
2.
2. You have to use that same X value. At 2, what is G prime?
1/3.
A third. And what is the reverse of a third?
3.
3. Which means that P prime at 3 is 3. Okay, yes?
Do we not change the sign for the reciprocal?
You do not change the sign. It's perpendicular lines that you switch the sign and flip it. For inverses, they are same sign reciprocals. Okay, next question, E. Must G of X have a root on 0, 2? Now, this is an interval. So, from 0 to 2, what happens to G? Okay, first of all, what does root represent? What number?
It gets larger.
Okay, true, but what special number does root represent? Oh, no, you're Algebra 2 teachers. Okay, should have taught you that a root...
They're like
Yeah, they did tell you that? Okay, good. So root, x-intercept, and 0 are all the same. So if I want to know if it has a 0, I need to know if it had to go through the x-axis. So what is G at 0? I'm going to go up to my table.
G at 0, 1/2.
Negative a half. What is G at 2?
3.
3. Did it have to go through 0?
Yeah.
What theorem says that?
Well, obviously.
Yes, what did you say?
Does it mean value?
Not mean value. Okay, think about, where is 0? 0's in the middle. It's an intermediate value. It's between them, right? So, you would say, must it have a thing? Yes.
Is it in?
IVT, that stands for intermediate because it's in the middle. Okay, guarantees this. Because, okay, and as we're going to go into our alleged dead week, okay, we're going to start reviewing, so let's review the steps. What type of function does it have to be for you to use IVT? Okay, it could be differentiable, but it just has to be continuous. So peaks, corners, all of that is fine. As long as it's connected, okay, you're allowed to use IVT. So G is continuous on 0 to 2. Okay, second, where does my 0 have to be? It has to be between them. And if it's going to be between them, then your endpoints can't be the same. So G of 0 was -0.5, and G of 2 was 3. And so my third step is that my number had to be between them, is between -0.5 and 3.
You have to write all that?
Yep. I mean, so when you use a theorem, if it's multiple choice, obviously not. But if it's a free response, you would be expected to use the theorem correctly. Okay, so you have to state, oh, it's continuous. That means it can't skip. These are my endpoints. The number I want is between them. Those would be your 3 things for IVT. Okay, the next thing. No, they're always just doing things over there. The next one is MVT. Okay, which is mean value theorem, and I know that probably y'all don't remember this one as much, so I'm just going to remind you. Mean value theorem says that f prime has to equal whatever the average rate of change is. So the answer is going to come out to be yes, but we're going to practice how to use it.
What was A-Rock again?
Average rate of change.
Yeah, but what?
Good question. F of B minus F of A over B minus A.
Oh, okay, I got you.
Okay, so if you got out your little cheat sheet, the first thing that you would, so let's go ahead and put yes, because. Okay, step number 1, G needs to be differentiable on 0 to 3. Okay, so for mean value theorem, it has to be differentiable. Okay, the second step is that you would find what the average rate of change is, which would be f of b minus f of a over b minus a. Now in this case, it's going to be f of 3 minus f of 0 over 3 minus 0. Look at your chart. What is f of 3?
F of 3 is 1.
Huh?
Oh, door, yes.
4. And then what's f of 0? 2 over 3 minus 0 is 3. What's 4 minus 2? 2 over 3. Is that the average rate of change then? Yes. Then is it guaranteed that f prime has to equal that? Yes, that's exactly what the theorem says. So then your third step, you would say, then f prime has to equal 2/3. Now, did it ask you to find it? No, you can't find it because you don't even know what f is to begin with. But if you did, you'd take the derivative, set it equal to 2/3. All right, turn over to the back. Huh? Oh, no. All right, I want you to do this one. And I want you to think about, this is like exactly like the table, but they're just giving you the information in a different format. Okay? So think about it. You want the equation of a tangent line. What 2 things do you need? Point and the slope. And what do you know about f and g? They're what? Inverses. So set up a table for me. Which function do we know stuff about? F or g? So I'm going to put f on this side. I'm going to put g on this side. What do I know about f? What's my point?
2, 3, 2.
Okay, 2 and
-3.
2, -3. And what do I know about my slope at 2?
It's 3/4.
It's 3/4. They're literally giving you the information. You just have to know what to do with it. So if f and g are inverses, what is g's ordered pair?
-3, 2, and 4.
-3, 2. And what is his slope?
4/3.
4/3. So then now can we write the equation of the tangent line? Okay, yeah, what would it be? 2 equals 4/3 x plus 3. Got it? I know. Remember stuff about even and odds? We did this, right?
Yeah.
We talked about this?
That Bill run already.
Yeah, I don't know. Okay, for even functions, what is true about f of a and f of negative a? They have what? The same or opposite signs? The same sign. And for odd functions, what is true about f of a and f of negative a? They have opposite signs. Okay? Then remember, the derivative of an even function comes out to be what? Odd. And the derivative of an odd function comes out to be even. Edwin, you missed this too. Okay? So, the reason that matters is that if I know stuff about f of 4, I can figure out stuff about f at negative 4 if I know what kind of function it is. So, let's do a first. We know that f is odd. F is odd. So if f of 4 is what? Look at the problem, it gives it to you. F of 4 is what?
3.
That's f prime of 4. What's f of 4? 6. Then what does that make f of negative 4? Negative 6. Yes, good. Okay, because remember, if it's odd, the y value has to change sign. It has to be the opposite. Okay, now let's talk about f prime. If f is odd, what does f prime have to be? Even. So if f is odd, its derivative switches to be even. And what do we know about f prime at 4?
3.
Y'all said it earlier, 3. Then what does that mean f prime is at negative 4? Negative 3. Does that make sense? So your answer, it said to find f of negative 4 and f prime, that would be this one and this one. Those would be your answers. Okay, so I want you to try to do B now. This time you know stuff about g at 4, and you want g at negative 4 and g prime at negative 4. So try to do the same thing. But what is g this time?
It's even.
Even. So that's going to change things a little bit. Are you doing letter B?
Yes.
Good. Okay, if g of 4 is 8 and g is even, what is g of negative 4? Still 8. Because remember, even, you have to keep the same sign. Okay, if g is even, what is g prime? Odd. And so if g prime at 4 is negative 3, what is g prime at negative 4?
They're odd, so it's 3.
Positive 3. Very
Gee,
good.
I don't even pay attention.
Okay, Sean, is that a good attitude?
What?
Okay, it might make someone feel bad that is having a harder time with it than you.
It's hard, actually.
Okay, everyone's
I
brain
understand.
is different. Alright, part C says H is F over G, and we want H prime at negative 4. What do we have to do? Take the... Okay, we have H, we want H prime. What do we need to do? Take the derivative. Okay, now think about what rule are you going to need if this is a fraction? Yes, quotient rule. Okay, so my high is going to be f of x. Yes, my ho is going to be g of x. Which means that if high is f, what's d high? What's the derivative of f? F prime of x. And if ho is g of x, what's d ho?
5x.
Good. And then from there, what's my quotient rule?
Hardy ho.
Oh,
Hody hi.
yep, because remember you
Hardy
want
ho. The holes are on the outside. Yeah.
the hose on the corner. Okay, over hose squared. Okay, so write your derivative, h prime equals. Now notice we're going to do h prime of x first and keep it very generic, and then we're going to plug in numbers after that. So, ho d hi, what would that be?
Oh, G of x.
G of x,
F of prime.
f prime of x minus f of x, then g prime, then divide by hose squared, which is g. Now, where do we want h prime at? What number?
H prime, we want F negative 4.
Good. So we already circled all of the or at least I did. I circled them all, so now we just need to plug them in. So what is g at negative 4? 8. What is f prime at negative 4?
3,
Negative 3. Minus, what is f at negative 4?
negative 6,
Negative 6. What is g prime?
3,
3. Divide by? G squared is 8 squared. Okay, is that good enough for a free response?
No, yeah.
Yes, you're done. Okay.
We wouldn't have to work it out.
Nope, unless it was multiple choice and you were having to pick an answer. Okay. Okay, last little section, we're doing some derivatives. Okay, do D.
Derivative.
Yep.
Does it say E raised
E to the f of x, yep. Okay, how do you take the derivative of e to the f of x? What would it
So it's
be?
gonna be E to the F of X and the, well, actually, is it product
F
rule?
prime.
You wouldn't need product rule because the f is the exponent on e. So f is plugged into e, so it'd be
So it'd be
e,
to the F of X times the the derivative of F of X.
which is f prime of x. Very good. And then where do we want it at? 4. Now, when we use 4, you need to make sure that when you're looking at this previous problem, okay, that you're using the positive 4 number. What was f of 4? 6. What was f prime of 4? 3. So my f of 4 is 6, my f prime of 4 is 3. So my answer would be e to the 6 times 3. Could you write it as 3e to the 6? Sure. Okay, now, why am I going to lose a point if this was a test?
It's equal to D.
Are these really equal to each other?
No.
What's different? This is the derivative at x equals 4, right? Okay, you want to make sure that you make some sort of notation there. Okay, next one. Do y'all remember what the little 3 tucked into the f means?
Yeah, the whole thing is raised to it.
So f of 4x, all of that is cubed. So let's take the derivative of that.
Why don't they write it like that?
I don't know. It's the same with like sine squared. It would be written the same way with the 2 tucked in. Okay, so outside we're doing crap to the third. What's the derivative?
3.
3. And then what's the power on the f4x?
Squared.
Squared. Times, now I gotta move in a layer. Now my inside function, pretend the 3's not there. Now I want the derivative of f of 4x. What's the derivative of f? F prime of 4x. And then what's the derivative of 4x in the middle? Times 4. So notice that that one had 3 layers instead of only 2 layers. You had the cubed, then you had the f, then you had the 4x. Now what is 3 times 4 in the front? 12. And then we want f of 4x squared and then f prime of 4x. Now what x value do I want here? X equals 1. But notice that when I plug in 1 here, what am I really going to find? F at what? When you plug in a 1 here, that's going to be f at 4. So look back up. What was f of 4?
6.
6. So you'd have 12 times 6 squared. And then when I plug in my 1 here as well, I'd have f prime of 4 times 1 is still 4. What is f prime at 4? 3. Can you leave it like that? Sure. Okay, nobody wants to do that.
Could you simplify it down to 36 squared?
30, yeah, you can do that.
This would be 36.
It would be 36 times 36. Yep, you could do that. That'd be great. Now, what I would say is if you're sure it's right, cool. But if you, on the AP test, got to here, and then let's say you made some mistake and just put 36, okay, you would lose your point. So you want to make sure, as long as you can go is fine, but it's also a time test. So the more time you spend messing with stuff on one problem, the less time you have to look at other stuff. Okay? All right, last one, F. We want to take the derivative of 2x squared g of x. What do we need? Yes, product rule. Good. Okay, so my u is going to be 2x squared. My v is going to be g of x. My u is going to be 2x squared. My v is going to be g of x. So if u is 2x squared, what's u prime? 4x. My v is g of x. What's my v prime? G prime of x. And then when you do your product rule, remember it's this diagonal and that diagonal added together. So it would be 2x squared g prime of x plus 4x g of x. And then what value are we taking this at? 4. So when we look at our g side, we would want to make sure we're using the two original, the OGs. So this one and this one, the positive 4x values. So g of 4 is 8, g prime of 4 is negative 3. What would I plug in for this x? 4. Very good. So at x equals 4, I would have 2 times 4 squared. What is 2 times 4 squared? Or what is 4 squared? 16. What is g prime at 4? Look back up. Negative 3. Plus 4 times, my x is another 4, and then what's g of 4? 8. Can you leave it like that? Sure. Okay? Alright. You have lots and lots of time now. Okay, look at how generous I am to give you all of this time to work and be productive.